All right, so the steps that we take is first, step one, you replace fx by y. Okay, and then, what's the next step? What do you do? Switch x and y, right? You switch x and y. So y becomes x becomes y. And what next? You solve for y. Okay, I mean, of course, to solve for y, you would add 1, right? Yeah, but basic approach is to solve for y. And when you do this, you basically forget what was here. You're only focusing on this one. You're trying to solve for y. And solving for a variable is like undoing something. Solving for a variable is undoing something. So in the morning, you took a shower, and then what do? You put your socks on, and then as you go out, you put your shoes on, right? Now, when you go home, do you take your socks off first, or do you take your shoes off first? Shoes, of course, because that was the last thing on, right? So what I'm trying to say is that think about what operations are done, and you undo the last operation. So look, you took y, and I view it like this. You have y, and what you do is you take the reciprocal, right? And then multiply by 2, and then subtract 1. Right? That's the sequence of events, right? You get what I'm saying, right? You have y, you take the reciprocal, multiply by 2, and you subtracted 1. Now, how do you undo this to recover y? You do the opposite, right? So the first thing you would do is you add 1, right? And then, so you're here. How do you go from how did we go from here to there? How did we go from here to there? We multiply by 2. So how do you undo that? Divide by 2. So I would divide both sides by 2. So divide by 2, divide by 2. And that gives you x plus 1 over 2 equals to 2 divided by 2 is 1, right? Okay. How do you undo this? You take the reciprocal, right? So you take the reciprocal, and you get x, reciprocal is 2 over x plus 1 equals to y over 1. So y is 2 over x plus 1. Yeah. Looks easy if I do it, right?
Yeah, it does.
Okay, well, but actually, you could run into several pitfalls when you try to solve this. So let me write down the answer first, and let me talk about other ways of solving this. So since y is 2 over x plus 1, the answer will be 2 over x plus 1. That's the answer, okay? But let me try to talk about some of the pitfalls. So again, we're here, x equals to 2 over y minus 1. Adding 1, that's a no-brainer. Everyone would do that, right? Now, you could opt to multiply by 1/2 both sides. What happens if you do that? This 1/2 and 2 cancels, and you get 1 over y equals to 1/2 x plus 1. And then you multiply this out, so you have 1/2 x plus 1/2 equals to 1 over y. And since you have two fractions, unfortunately, if you have fraction equals to fraction, it's true that if you flip both sides, b over a equals to d over c. That's true. But if you have more than one term, that's not true. If you have like a over b plus, or let me give you an example. What's 1/2 plus 1/3? If you do the calculation, you'll see that this is 5 over 6. Okay. This 1/2 is 3 over 6. 1/3 is 2 over 6. 2 plus 3 is 5. Right. So this is true. Agreed?
Yeah.
Are you okay? All right. Now, If I flip this, that's 2. If I flip this, that's 3. If I flip this, that's 6 over 5. Are these the same? Well, 2 plus 3 is 5. That's way bigger than 6 over 5, right? So this is unfortunately not true. You can't flip more than one term at the same time. So that's the problem here. If you have more than one fraction, you can't flip. So the only way you can get out of here is by putting the entire thing and flipping it. So think about this entire thing as over 1. It's this gigantic fraction. So you flip this and you get this equals to y, right? And it looks ugly, right? And it doesn't look like this. How do you turn this into this? Any suggestions? Huh? Multiply 2 top and bottom. If you have fractions inside fractions, you can use the property that any fraction you can multiply the same number top and bottom. If you do that, 1 times 2 is 2. 2 times 1/2 cancels and you get just x. 2 times 1/2 you get just 1, and you get this. That's how you get that.